Problem 7.12. The end A of a rod AB rotates about O while the end B slides along a straight line. A crank CQ oscillates about Q. Draw the locus of the midpoint P of the connecting link CD for one revolution of the crank OA. AB equals 1500 mm, CD equals 750 mm, OA equals 450 mm and CQ equals 1200 mm. Divide the circle in 12 equal parts and number the paths. Extend the center line 1O such that it passes through the end B of the rod. Then draw lines of size equal to AB from all 12 points of the circle up to line OB. We will determine the various positions of point D as follows. Point D from the end A. Now take the same distance from point 1 on the circle and mark point D1 on the line 1O. Similarly, mark point D2 to D12 on their respective lines. The point Q from the extended line passing through the end B. Observe that the distance CQ is given. To determine the path of point C, draw an arc with radius and taking center as Q. Now, with centers D1, D2, etc. and radius CD equal, draw arcs cutting the above path of C at points C1, C2, etc. Next, locate the midpoints of lines D1, C1, D2, C2, etc. and call them as D1, D2, etc. The required locus of the midpoint P is obtained by drawing a curve through these midpoints. Thus, we can determine the locus of a midpoint of a link in the 4-bar mechanics.